The last kind of reaction you should be aware of is known as the oxidation reduction reaction. Oxidation and reduction, you might be surprised, but your breathing process, known as respiration, is a kind of oxidation reduction reaction. Oxidation is defined as one of the following, and that's either loss of electrons, or loss of hydrogen atoms, or gain of oxygen atoms. In higher chemistry, such as organic chemistry, we define oxygen specifically as loss of hydrogen or gain of oxygen. But in our case, more simple cases, simply it's a loss of electrons. So if you see this part, oxidation is happening here when magnesium metal, the neutral atom of magnesium metal, loses 2 electrons to form Mg2 plus. This is known as the oxidation half reaction. Why is it called half reaction? Because oxidation and reduction always go hand in hand. You cannot just have oxidation without reduction. You must have both happening at once. So this is one half of the reaction. While this is happening, what's the second half? It's the reduction half. So if oxidation is the loss of electrons, reduction is the gain of electrons. If oxidation is the loss of hydrogen, reduction is the gain of hydrogen. And if oxidation is the gain of oxygen, reduction is the loss of oxygen. But like I said, in the case of oxidation, similarly in the case of reduction, we will simply look at cases where we gain electrons. Just like in oxidation, we look at cases where we lose electrons. Here we have chlorine gas, that's neutral, a diatomic gas. If it were to gain 2 electrons, it would form 2Cl minus. Each atom of chlorine now has 1 extra electron, and so both of them put together have 2 electrons, each one more electron than the neutral version. And this is the reduction half. So oxidation and reduction happen together. We combine both of the halves in this form. Here is the magnesium oxidation half, and here is the chlorine reduction half. Now when you were to write this reaction as one whole reaction, the 2E minus on each side of the reaction cancel out. Whatever happens to occur on each side of the reaction in the same form, you cancel them out. And the final form looks like this. What you see down here, Mg plus Cl2 gives you Mg2 plus and 2Cl minus. And that's our oxidation reduction reaction. Now there is another terminology that's applied to oxidation reduction reaction, and that's about having something called oxidation agent and reducing agent. Oxidizing agent and reducing agent. Oxidizing agent is some reactant which itself gets reduced, and when it does get reduced, it gains electrons and it causes oxidation. So if you look at this reaction, who is getting reduced? Who ends up gaining electrons? It's chlorine. So instead of calling chlorine as the one who gets reduced, we can call it as the one who is the oxidizing agent. Similarly, on the right, the reducing agent here, it's the one who gets oxidized, loses electrons and causes reduction. Magnesium is the reducing agent. Now why make this more complicated by having this new terminology added to this discussion? It's because many times chemists are looking specifically for some agent, some oxidizing agent or some reducing agent who gets the job done of either causing oxidation or reduction. They don't care about the identity of the exact compound they use. So they may perhaps stick with chlorine as the oxidizing agent, or something that is better at doing that exact thing of causing oxidation. And so we have that extra terminology added to this process of oxidation and reduction.